Okay. So surface chemistry, as the name states, it is very, very literal. So it has to do with the chemistry, like chemical phenomenon that happens on the surface of something, surface of materials. It could be metals, non-metals, like whatever, crystals, charcoal, basically the phenomenon that happens on the surface. And it's not just solid case surfaces, even within, let's say, solutions or gases, wherever you have a surface, like that's the interface between two things, all of the chemical phenomenon related to that. Okay, so in this chapter we'll mainly look at three things. One is adsorption, which is different from absorption. This is adsorption. Okay. And then we look at catalysis. Again, like catalyst action happens, a lot of it happens like on the surface of it. So catalyst action mechanisms and how it works and all of that. And then we have colloids. So these are like the main things that we are going to study. Okay. Just a moment. I'm just gonna. Yeah. Okay. So these are like the three phenomena that we are going to study about in this chapter. Okay. Shantanu, where are you? Video is off. Okay. So we'll start off with adsorption. We will do adsorption today, hopefully catalysis also, but if not both, at least absorption and most of catalysis we'll be doing today. Colloids completely will focus on it tomorrow, because there's like a lot of concepts related to colloids. This is relatively easier. Okay. So adsorption. What do you know of adsorption? What do you mean by adsorption? So this sounds very, very similar to absorption, right? What do you mean by absorption?
Taking in of something like, sponge and water.
Very good, very good example. So if you put sponge in water, the whole, like the water is going to go inside the sponge. Even if you consider, like if you cut that sponge in half, the whole thing is wet. So the sponge absorbs water completely. Adsorption is similar, except it's not going to go completely inside. This is a surface phenomenon. So basically, adsorption means it's the accumulation of molecules on the surface of a substance. Okay, so it's accumulation of molecules on the surface of the substance. So if you were to see a visual, in the case of absorption, if this is your sponge, then the water is absorbed completely inside, like there's water molecules even in the center, like even like in the whole bulk of the sponge you will find that water. But in the case of adsorption, suppose you have something like charcoal, then the gas molecules are, you won't find any gas inside. The molecules will be accumulated like right on the surface, only over here. Okay. So that is the difference between adsorption and absorption. So this is absorption and this is adsorption. So absorption is throughout the bulk. Adsorption is only on the surface of this thing. Okay. Why, like what is this weird phenomenon that's happening, why it happens and all that we look at in this whole section. But before we get on to it, there are some words that we'll be using throughout. So get familiar with them. One is adsorbent and adsorbate. Okay, so adsorbent is this is the bulk, like this is the brown structure that I've drawn here. The surface on which the adsorption is happening, that is adsorbent. It's adsorbent, that's why like it is capable of, you know, of the phenomenon adsorption. So this is the material that is adsorbing. Like the surface on which, like jiska surface hai, that is the adsorbent. And adsorbate is, this is the blue molecules that is actually accumulating over it. So this is the substance that that is like accumulating over there. Okay, so yeah, the thing that is accumulation, nahi, that is grammatically wrong, that is accumulating or being absorbed. So it is the substance on which, like on the surface of which the adsorption occurs. Okay, so adsorption is this process. Apart from this, there's iska opposite of adsorption is called desorption. So adsorption is the process of accumulating. Desorption is, you know, when the adsorbed particles are floating away. So that's desorption. So it is the process of removing adsorbed substance from the adsorbent. Okay.
I'm so sorry, ma'am. Could you just like uh,
We'll just do
like go over it
So
again?
we were just discussing like all these are terms, introductory terms we'll be using. So surface chemistry, basically we'll talk about all the phenomenon chemistry that happens on the surface of these things. So three main things we look at in this chapter are adsorption, catalysis, and colloids. We're gonna study about all these three. Again, this whole chapter, it's very, very basic. Like this whole chapter is going to be like, हाँ ये होता है, ये भी होता है, और इस तरह होता है. It happens in this case, and then there is this case also. Very, very
Okay.
theoretical, informational sort of a thing. So you'll have very few numericals, barely any. Okay. So the first thing we'll tackle is adsorption. So what is adsorption? It is the accumulation of molecules on the surface of a substance. So this is quite important. Yeah. Shantanu, you were saying something? No? Okay. So like you've heard of absorption, which is basically when something is taken all the way in. Think of sponge absorbing water. Like the particles are going all the way into the bulk of the substance. That's absorption. In the case of adsorption, they just remain on the surface. They're not, if you cut charcoal in half, you won't find any gas molecules on the inside of it. It's only on the surface. Okay, that's like an important distinction between absorption and adsorption. So you need to be careful about like what word you're using. It's a very, very simple word. Some terms related to adsorption, you have something called adsorbent and something called adsorbate. It's just the substance that on which on the surface of which the phenomenon happens. It's adsorbent, like adsorbent surface, वो absorb कर सकता है of something else. And adsorbate is the substance that's like accumulating on the adsorbent, like the substance that's being adsorbed. So adsorbent is the brown thing, that's why I've color coded it, and adsorbate is the blue thing, the thing that's accumulating on the surface. And the opposite of adsorption is desorption. So adsorption may there is accumulation of these particles. Desorption may when these particles diffuse away from here, like the process of removing the adsorbed substance from the adsorbent is called desorption. Yeah. Clear till now? Like familiar with the words? Have you guys noted
Yes,
down?
Just a second, I'm on desorption.
Okay. Shantanu, noted? Done?
Yes, ma'am.
Okay.
Done, ma'am.
Ma'am, can you give an example of this phenomenon that we might know?
Oh
But,
yeah,
like, we don't
absolutely.
know that
There's
it's
lots
adsorption.
of examples here. So once you're familiar with the terms, then we look at cases.
Okay.
So where
Ma'am, sorry, could you just go back for a second? From the adsorbent. Yes, ma'am. Done.
examples? So one I've written here is misty windows. If you've seen misty windows, like condensation happening on cold glass, yeah, winter season may, rainy season may. So that's adsorption, you can say, because glass pane hai, uske upar water molecules are getting, like they're settling down here, they're getting attracted to the glass and they're like sticking to the glass. Yeah. Another place you may find is I've written here paint, like paint sticking on surfaces is also like adsorption. Water filter, this is a good one. Have you guys ever used charcoal, or have you heard of like charcoal being used to purify water?
Doesn't charcoal act as a coagulant?
Coagulant, yes, but the chemical phenomenon that's happening is adsorption there. Like
Okay, because like when you drop charcoal in water, I think all like the particles and everything, they get accumulated at one on the charcoal, I think.
On the
itself,
charcoal,
and then you
that's-
remove it.
Yes.
Okay.
That's adsorption. That's charcoal absorbing all the impurities. So charcoal is one, not just water filter, but air filter also, can I say? Purification of air, basically. For this also you use charcoal, you use alum. Like how do you keep your fridge smell free?
That I have no idea about.
Go home and like if you, I mean, I don't know what fridge you have. Abhi to like the fridges come equipped with, you know, the circulation and all that. But otherwise, a lot of times the compressor, like fridge ke andar, it starts smelling weird. Also, when you store foods, like if you don't close it, food ka smell also like keeps circulating in fridge is sealed surface. So how do you remove that weird smell from fridges? At least in my grandparents' house, I've seen this. You put a little bit of alum. Alum is like a white crystal. Or some people also put charcoal. Works the same way how charcoal works in water filter. Some people put baking soda. This I have used myself. Like just take like a plate and then spread a thin layer of baking soda, baking powder, and yeah, that basically. Even coffee is set like coffee, ground coffee, not the instant coffee, like the beans that are ground. So that's set to. So all of these adsorb these selected gases from the fridge. So that's how they remove the odors. And yeah, like they absorb it. Like we say they absorbs bad smell and all that, but no, chemically what is actually happening is adsorption. All the gases settle on the surface itself. Then you take it out, then you heat it, desorption occurs, and then you can reuse it. Yeah. So what else is there? Silica gel. So this you guys must be pretty familiar with. If you bought like a new bag or a Tupperware container or a water bottle or something, even toys, something that comes in boxes basically. You must have seen it. There's a little bit of silica gel.
Yeah, but I'm not sure whether it's silica gel because it's solid. Because like shoes, when we buy new shoes, then there's like this packet thing where it's just like do not open, do not consume, not
Yes.
for kids or
That
top
is
of
not
it,
only
keep it
there
away.
in the shoes. No, we get in those new Milton bottles
Yeah,
and
it's in a
those
lot of
Milton
new
ka
things.
dabba.
Okay, so that is
Yeah.
silica gel.
Yeah. So
It prevents from the moisture. It absorbs moisture and stuff.
correct.
Okay,
Except
so that's why it becomes solid. So when
yes,
they must put it, it
it
must be
doesn't
like in
become
a.
solid. Like it.
No, it is. They are
solid.
like balls only. It is
Yeah.
jelly ball-like
I
structure
have
only.
never opened it because it said never to open
No,
it.
no, I did open it. I feel it.
No, it's called gel, but it's not like your toothpaste ka gel. Okay, so gel is a name that we give for colloids in which I think it's gas trapped in solids, gas trapped in liquids. We'll come to that. So gel is a specific name to colloids where the phases of, like, what do you call it? The solvent, like dispersion medium and dispersion state, are very specific. Gas and solid, gas and liquid, ऐसा कुछ तो है. So that's how silica gel is prepared. That's why it's called a gel, but it is like a hard substance. It's not like toothpaste ka jelly. So what happens is it absorbs water or moisture, water vapor basically. And we want the water to be absorbed because especially like water bottles and all, if there is moisture being retained, then it can lead to all sorts of problems. Sorry, there's a sudden disturbance here. But yeah, presence of moisture, they can be like fungal growth and all, which we want to avoid because it's brand new. We want it to be perfect. So put a little bit of silica gel, absorbs moisture. Okay. And there are a few other applications also. Let me see what your textbook has given. When you want to remove the color, like bleach is chemically permanently removing the color, but there are other ways of removing color. Charcoal is one. If you add charcoal to a solution of methylene blue or methylene orange or something like an organic dye, it absorbs all of the dye, solution becomes colorless. So like lab wise, you have a lot of applications, observations that you can see for adsorption. Yeah, but these 4 points are what you would observe in real life, like in your everyday life, without knowing about it. Okay.
मैं बोलूंगा फिर ऊपर ले लेना.
Yeah, there's some construction happening here, so there's going to be some disturbance. It's right outside the window. Okay, anyway, so these are like examples of adsorption. So charcoal in organic dyes also absorbs. Okay. So let's talk about the mechanism of adsorption. What happens here? This whole chapter is going to be like this, okay? It's just information. So it'll be very theoretical. Like, why does adsorption happen? Like, what makes the particles accumulate or stick to the surface? Okay. So the whole key lies in van der Waals forces. That's like the main reason or primary reason why adsorption happens. Do you guys remember what are van der Waals forces?
Ma'am, they're weak interactive forces between molecules.
Absolutely. Are they attractive or repulsive?
They're attractive.
They're attractive, right?
Attractive.
Correct. So what happens is, it all starts with that solid, like the bulk of the substance. It is made up of molecules, particles, molecules, atoms, whatever it may be. All these particles are there. Solid matlab, yeah, they're tightly packed against each other. Focus on, let me put up some more layers here. Easy to see. Okay. Focus on a particle that's somewhere in the middle over here. So this is going to attract, what do you call it? Experience van der Waals forces from the particles around it. So I'll just magnify this. This is the red particle I've chosen to show. So it's going to have forces. Yahan se, it's going to face attractive forces. Like there's going to be forces on this side. It's going to attract this molecule. It's going to attract this molecule. It's going to attract niche ek wala molecule. 3D matlab aage piche bhi hoga. What will be the net force experienced by the red particle?
Ma'am, could you repeat that?
So this red particle that's somewhere in the middle, within the bulk of the substance, it is going to it's going to experience attractive van der Waals forces from all the particles surrounding it.
Yes, ma'am, from all the neighboring particles that are touching it.
Yeah, correct. So what will be the net force on this particle?
Ma'am,
All of them?
like in my head, it should get cancelled out.
Absolutely, that is right. So all of them are the same particles. Like agar iron atom hai, to ye sare iron atoms hi rahenge. So in that sense, physically, chemical properties, there is no difference, which means that the magnitude of force that it's going to face is all going to be equal. And if it's in all the directions, it's also going to be opposite to each other. So they all cancel out. Okay. So net force will be 0, which means the red particle, all of the forces are balanced. Now let's look at a particle that's on the surface, because adsorption is a surface phenomenon. So that I'll highlight in green. Let's take this green particle. So ऊपर का green color का ये particle है. What can you say about the forces that this green particle experiences?
Ma'am, not all of them would be cancelled because it's on the surface.
Correct. So surrounding it, ये दोनों cancel हो जाएंगे. आगे पीछे also maybe they get cancelled out. But whatever is on the bottom, like it's going to, like there is nothing else on the top, so
It will
has
exert
van der Waals
pressure.
forces. It won't exert pressure outwards, but it will have van der Waals forces, attractive forces that it's going to.
So it won't be 0.
Yes. So the forces on this green particle that's on the surface are unbalanced. And it is because of this unbalanced forces that, if I have a random, gas molecule, gases are just everywhere. Or if I put it in liquid, maybe. So basically, if there's a random molecule from the surroundings coming close to it, it's going to experience these van der Waals forces of attraction and it's going to stick to the surface. So the same is the case with all of the surface molecules. That is why adsorption happens only at the surface level, only on the borderlines. Okay, so that's like the core, this thing of adsorption. But this doesn't happen everywhere, right? Like obviously we have lots of solid surfaces. There's a glass table, there's like a plastic phone, plastic bottle, plastic cup, paper is there, books are there. But how come we still have an atmosphere? It's not like every single gas molecule is accumulating on whatever surface is available, right? So in addition to van der Waals forces, like yeah, van der Waals force is the primary thing that's attracting this. But also look at what's happening. When the force is attracting this particle, there is a bond being formed. Like not a chemical bond, not like ionic or covalent bond, but there is some sort of like attractive forces, matlab, there is some energy changes involved, right? So the process of adsorption involves a delta H, and because it's always like attraction, delta H is always negative. Okay. Also, think of the process that is happening here. The orange particles, initially they were in gaseous state. Gas is being converted to, once is sticking to solid, it's stuck there, gas on solid. So during this process, what is happening to the entropy? Entropy increases or decreases?
Because it's getting stuck, there is no random motion, right? So the entropy will decrease.
Entropy decreases, which means delta S will be what? Positive or negative?
Negative.
So initial, like S initial minus S final kya aa raha hai? Is this a positive value or negative value?
Oh, negative.
Huh? Entropy.
Positive was S initial
how
is
is it
more than
negative?
S final. No, it's not negative. Sorry.
Yeah, it's
S,
positive.
yeah, S initial is greater than S final.
Correct. So entropy, change in entropy is also, so initial minus final is a positive value, which means that so S initial minus,
yeah, it's a positive value.
Positive value, but delta ke liye always take S final minus S initial. So this will be a,
Yes, ma'am. Can you repeat that?
so initial minus final is a positive value. So final minus initial is going to be
Negative.
negative. So delta S is also negative. Okay. Now think back to thermodynamics that you studied in grade 11. Do you remember the equation for spontaneity? Like, do you remember what is delta G?
It's delta H minus T delta S.
Very
If
nice.
that, yay!
Right. Awesome. Now, if a reaction or a process should happen versus should not happen, how does that relate to delta G? Like spontaneity के लिए conditions क्या है? So if it's a spontaneous process, like if it will just happens, that means delta G should be positive or negative. You guys remember that? Gibbs free energy.
Ma'am, now but I know that both of them have to be like negative or positive for like it to be a spontaneous reaction.
Like
Now I don't know which one.
In general, this total delta G, if it is negative, that's a spontaneous process. So if delta G is positive, then the process, it's difficult for that process to occur, like be it a reaction, yeah, whatever we're talking about. So this is non-spontaneous. Yeah. So let's apply that to our adsorption process. So in adsorption, So
Can you
delta
just go
H,
to the previous slide for a second?
I'm rewriting the last thing. Like this, I'll rewrite it.
Just one second.
Yeah, yeah. So okay, note down.
No, ma'am, done.
Okay. So in adsorption, delta H is already less than 0 because we saw it was negative. Delta S is also less than 0 because entropy kam ho raha hai. So for delta G to be less than 0, the value of delta H and T delta S should be such that the total ends up being negative. Like the delta H should be high enough that it overcomes the positive value of this minus T delta S. Okay. So only when that happens, then adsorption can take place. Otherwise, in universe, naturally speaking, it won't happen. You need to put in some effort to make this less than 0. Okay. I mean,
Yes, ma'am. So we won't know until we've gotten like a certain values and we've calculated whether
Yeah.
delta G is greater than or less than 0.
correct. That is why you
Okay.
observe adsorption in certain cases, like purification of water, air purification, like catalyst, like adsorption of hydrogen on nickel. Like adsorption does happen in the universe, but it's not always. Like it depends on the energy exchanges. Only when delta G is less than 0, then it will occur. Otherwise, normally, if you're just living your life, it's not going to occur. Like that's why your atmosphere still has gases, like all of them are not accumulating over stones and soil and buildings and all of these. Okay. So two criteria for adsorption to occur. The mechanism, like what causes adsorption, is the unbalanced van der Waals forces on the surface molecule specifically. Another criteria is, again, it will happen only if delta G is negative. So for a particular pair of adsorbate and adsorbent, they're going to have some energy changes, entropy changes. So depending on this, only then it's going to occur. That's why it will depend on the temperature also. Sometimes adsorption will happen at certain temperature, but that's the whole point of desorption, right? If I increase the temperature at higher values of the temperature, it's going to release all of the adsorbed substances, because at specific temperatures, then the delta G becomes positive. So
Ma'am, but then there must be like a, like a sweet spot where the temperature is just right and then
absolutely,
absorption, I mean,
Yeah.
the reaction is spontaneous. So
Yeah.
so that must differ from reaction to reaction, right? Or
Yes, it depends on the pair of substances that you're considering.
Okay.
Yeah.
So ma'am, adsorption, just to clarify, adsorption will only occur if there are unbalanced van der Waals forces on the surface of the material
That
between
will
like the
always there.
molecules.
That too is always
Huh.
there. That's a
Hmm.
property of the surface molecules. इसलिए हो रहा है.
Okay.
Hmm.
Okay. And it only occurs if the reaction is spontaneous. That means
Yes.
delta G is less than 0.
Correct.
And last
Delta
one
G
was
less
that it
than
is
0
temperature dependent.
मतलब when you say delta G less than 0, that automatically depends on the value of
Okay.
delta H also, T also, delta H, S also.
Okay.
Yeah. So delta H in adsorption is always 0. Delta S is also always less than 0. When this is also negative, this is also like negative into negative, ye positive ho jayega na. So there it depends on the numbers ki which number is greater that way. Okay. This is the mechanism of adsorption. Like this kind of explains why adsorption happens and why does it not happen in like all the cases at all temperatures, all of that. It's a trade-off of these three. Then we'll talk about types of adsorption. So depending on what is happening on the surface here when adsorption occurs, You have two types of adsorption. You have physisorption and you have chemisorption. Yeah. Again, you can look at the words and kind of figure it out. इसमें chem है, इसमें physi है. Kind of like how you have physical properties, chemical properties, that way. Physisorption and chemisorption. So physisorption, chemisorption, I'll do it as a difference, like a split side-by-side thing. I think you have a table also given in the textbook in the all-in-one. That's very convenient to follow. Whatever you are given as properties of physisorption, properties of chemisorption, same thing factors into the difference as well. So we'll do a comparative thing for this. Physisorption, it is purely a physical process. So the adsorption that's taking place, only van der Waals forces are involved in it. Like the adsorption that happens, like when adsorption happens only due to van der Waals forces coming into picture, then that is physisorption. Okay. Instead of saying, so it's a physical process. In other words, it happens because of van der Waals forces alone. Why are we stressing on van der Waals forces alone? Because in the case of chemisorption, there are chemical bonds involved. So in the case of chemisorption, if I have a substance here, surface molecules hai, another molecule comes, diffuses here, there's literally like a chemical bond formed between the surface molecule and the gas molecule or liquid molecule, whatever, adsorbate molecule. Okay. So physisorption is completely physical. In this case, the chemical bonds are formed. It is because of chemical bonds being formed between the surface and this thing. So whatever properties follow are caused purely because of this. Now, where do you observe van der Waals forces? Like, or let me put it this way, van der Waals forces, does it depend on what two substances are involved, like what two molecules you're looking at, or is it like universal?
Ma'am, van der Waals forces exist between molecules, but again, it does depend on which molecules, because then there are other types of bond formations as well, right?
There are other types of bond formation, but does that mean that van der Waals forces go away?
No, ma'am, they're there.
They're always there. Van der Waals
They're
forces
always
are
there.
universal.
Even in a small, yeah.
You know, so in the case of physisorption, the particles are not specific. Like, for example, if you have a piece of charcoal or alum or something, it can absorb any kind of gas. No, it's not specific that I'm going to react only with, I don't know, carbon dioxide, but I'll leave nitrogen, oxygen, everything else alone. Aisa nahi hai. So it is not specific. There is a lack of specific, like there's no preference towards specific substances. But in the case of chemisorption, because we have chemical bonds being formed, again, like random things don't react with other random things. Like there is some sort of selectivity involved, right? With when it comes to reactivity. So at chemisorption, it is characterized by the particles are very specific. You know, I will only absorb this particular substance because I can form a chemical bond with this, not anything else. So this is defined by specificity, like it is, or we can say it is highly specific in nature. Then what else do we talk about? Oh yeah, think of physical and chemical changes. Similar to physical chemical changes, physisorption is reversible. Chemisorption is not reversible, it's irreversible. Like you need to put in some energy changes to reverse that thing. Because you got literal bonds being formed there, so it's characterized by, it's not reversible. In physisorption, the rate of adsorption depends on the physical characteristics of the gas. Specifically, how easily liquefiable it is. So when we say nature of gas, we're talking about the liquefiability. I don't know if that's a word. Basically, how easily liquefiable that gas is. So easily liquefiable gases. Can you guys figure out what is the logic or connection between being easily liquefied versus being readily adsorbed?
Ma'am, the rate would be, it should be like inversely proportional. If it's easy, if it's a gas which can be, wait, let me like,
Think of the why certain gases are easily liquefiable. What comes into picture when gas is being converted to liquid versus see what is the connection with adsorption. Shantanu, you don't have to be so quiet. You also can give a try.
ma'am, I will give it another go. So rate of adsorption depends on the nature of the gas. That means as if the gas is easily liquefiable, that means it can easily go from gas to liquid. That means its molecules can come closer together after, quickly, rather than just like taking a lot of time. And because the molecules will come closer together, they'll be like, the Waals forces will be like maintained,
Yes.
and the what is it called, the adsorbate, I think.
Wait.
Yeah, the adsorbate will be like adsorbed. I don't know if that made
Yes.
sense, but like you
Correct.
got it.
Absolutely. Van der Waals forces is what I was looking for. So easily liquefiable matlab, something gets converted to gas, from gas to liquid. When that happens, molecules coming closer together. So if a particular gas is easily liquefiable, the van der Waals forces between those gas particles are much more. That's why they're attracting all the other particles towards themselves and then they become a liquid. So if the van der Waals forces are much more, that will help with adsorption because all of that is caused due to van der Waals forces. Okay. So rate of adsorption in physisorption, it depends on how easily liquefiable the gas is. Which ties into the nature of the gas itself. It's like an inherent property of the gas. In this case, in chemisorption also, the rate depends on the nature of the gas, but in this case, it's more of how easily can it react with the adsorbent rather than liquefiable nature. So here also rate depends on nature of the gas, but it's a different nature of the gas that it depends on. So this is the reactivity with the adsorbent. Okay. So both the rates depends on the nature of the gas. In this case, it depends on the critical temperature, like how easily it can be liquefied. In this case, it depends on the reactivity.
Ma'am, but could you elaborate on why does it depend on reactivity with like the adsorbent?
Chemical bonds are being formed, right? So some molecules capable of forming bonds with a particular substance, other molecules not really. So
Ma'am,
depends.
but if
Sure.
so, what? So I don't know because like I don't remember doing this chapter, so I'm like I don't have past knowledge about this. But shouldn't in adsorption, like the phenomenon, shouldn't the molecule be on the surface? If it reacts with it, wouldn't it produce like a byproduct or something like that, and like things will like
See,
evaporate?
makes sense what you asked, but adsorption, it is accumulation on the surface. Specifically in chemisorption, it is accumulating because of a chemical bond being formed with the adsorbent.
But then is the entire molecule just on the surface of the adsorbent?
I'll show you this with an example, okay?
Okay, okay.
Hydrogenation कैसे होता है? You remember hydrogenation?
And if you take an organic, if you take a hydrocarbon, then you will add hydrogen in the presence of palladium, nickel, and then you will, if you take an alkene, you'll get an alkane.
So it's
So you'll
basically
get
addition
ethane.
of hydrogen in the presence of,
Yes,
like, let's take nickel.
yes.
We're just considering an example, and you get a product, right? So how does this reaction happen? So there is nickel, which is a solid, like metal here. When hydrogen is a diatomic gas. So when hydrogen gas diffuses onto nickel, this bond breaks and this bond is formed. So this is H and this is all Ni. So this sort of a chemical bond is being formed. At the same time, ethylene gas is also coming in. So double bond may, one of this bond breaks and that also forms a bond with
Nickel.
Nickel, yeah.
Okay.
But when you have a hydrogen here and a CH2 like part of ethene over here, it is more stable when this H forms a bond directly with this rather than staying with nickel.
Okay.
So that's how the chemical reaction is carried forward. But
Whenever there's a catalyst present.
yeah, but the first step is always adsorption. And in this case, it's not just being attracted due to the van der Waals forces, but there is an actual chemical bond being formed between all of these atoms. Okay. So that's why
it's much better.
So that's why it's highly specific. Like we use only nickel catalyst because for the reactants that we considered, nickel works best. With the others, maybe it's like the heat of the reaction doesn't tally up. Maybe it becomes reversible. Maybe the rate is extremely low or extremely high. There's something that doesn't add up. With nickel, it is ideal for this particular conversion. So that's why we do that. So that checks in our specificity also. Not reversible because we are not getting hydrogen back. Like hydrogen is just bonded over here. So another thing that ties in with not reversible is that if I didn't add ethene over here, if I just diffused hydrogen over nickel, hydrogen is deposits over nickel surface and there is a type of hydride being formed.
NiH3 or something like that.
Yeah, NiH something. Yeah. So that's the reason D block hydrides, they're called, I think they're called interstitial hydrides. They don't have a set formula. It's not a perfect one-to-one stoichiometric reaction. Randomly hydrogens come deposit on the surface, they form these bonds, that's it. So you end up getting formulas like vanadium, like VH0.7 or something like that. Yeah. So like because of this phenomenon, this is another application of adsorption. If you have to transfer hydrogen somewhere, like you don't, gas tank cylinders like oxygen, nitrogen is one way. Converting it into hydrides and then transporting that solid from one place to another is another way that hydrogen is transported. So this is another application of adsorption. Okay, so specific, not reversible, the rate depends on these reactivity, like nature of the gas, but specifically how reactive it is with this specific adsorbent, not general reactivity. How is it reacting to this adsorbent? That's what it depends on. Then going with the rest of the things, so physisorption occurs at lower temperatures. Again, because it's a physical process and it's an exothermic process because delta H is less than 0. So based on Le Chatelier's principle, lower the temperature, better it is for physisorption. In the case of chemisorption, because you have bond breaking, bond forming, all of that involved, this happens in high temperatures. So low temps are favorable. And in this case, high temperatures are favorable or favored. Okay. There are a few, I think 2 or 3 more points we need to discuss. Let me know once you guys have noted this, then we'll go to then I'll shift the page and continue the differences.
Done, ma'am.
Cool. All right, Shantanu? Keep your video on, no? Like, or at least answer questions, keep responding. So if there's any part that you're not understanding that you didn't get, definitely ask. Otherwise, when you're doing the question fit, that's gonna remain as a doubt.
Miss, all this is clear, I've understood.
Okay. Next. All right. Again, it all stems from physisorption is physical, chemisorption may chemical bonds are formed. So that brings us to the next point. Both the cases delta H is negative, right? Now the range of delta H. So in physisorption, delta H is relatively lower. So delta H matlab enthalpy of adsorption, like the enthalpy involved with that particular change. So this is delta H. And in this case, delta H is high. Low high matlab like the range of values. Let me check. Oh wow. Okay. So isme range is around 20 to 40 kilojoules per mole. And in this case, it goes like approximately 100 something. Almost like 200, 300 kilojoules per mole. This is also kilojoule per mole, all per mole enthalpy. So the range, the scale of energy changes. That's the reason when you adsorb gases on charcoal in your everyday life, it's not suddenly bursting into flames. It's not getting insanely hot because the energy changes are it's very low compared to this. Okay. What can you say about the activation energy for both these processes? In terms of
For chemical reactivation, energy will be lower because, of course, in some of them you're using a catalyst.
in chemical, it is higher compared to this thing.
Oh, but don't you use like a catalyst in chemical reactions?
Reactions, yes. We're talking, just focus purely on the chemisorption part of it, only the adsorption part of it. And we are comparing physisorption with chemisorption. So physisorption, it occurs naturally, normally, because it's not very specific. You only need the van der Waals forces to act, which is why you don't really need a lot of energy for this to happen. Also ties in with, this happens at lower temperature, this happens at higher temperature, because again, bond breaking, bond formations are involved. So in this case, high activation energy. Spellings sometimes required. Okay. What else? We've spoken about temperatures, enthalpies, and energies. Oh, one last thing. Okay, both of them depend on the surface area. So more the surface area, or let's say it basically physisorption increases with surface area, chemisorption also increases with surface area. Both of them are surface phenomenon. So zyada surface hai to zyada adsorption hoga. This is a point of similarity. It's not a difference. Increases with surface area. Surface area, when I say surface area, it is the surface area that is available for adsorption. This also increases with the surface area. This is natural because both of them are surface phenomenon. तो ज़्यादा surface मिल रहा है, ज़्यादा adsorption होगा. Simple. Okay. So we talked about mechanism हो गया, physisorption versus chemisorption. Oh, so now we have adsorption isotherms. And then adsorption of gas from the solution phase. Okay. So we'll just take a little break now, because now we're going into proper physical chemistry territory. We'll look at graphs and analysis of rate of adsorption and all of that. Variation of adsorption with pressure, temperature, all that. We'll take
We'll take like a 5-minute.
Yeah, and then resume.
Okay, ma'am.
Isotherms. What do you mean by isotherms? Do you guys remember?
Ma'am, isn't it a graph where temperature is constant?
Absolutely. Iso meaning something same. Therm is temperature. So isotherm related to adsorption. So main thing is you're plotting it at a constant temperature. What exactly are you plotting on the graph? So adsorption isotherms are a graph between you plot pressure versus something called x by m. Okay. So x by m is like how you measure the adsorbent. It's literally a fraction. So this guy, a scientist named Freundlich, did a lot of work related to it. So they're also called Freundlich's adsorption isotherms. Spelling is this. Freundlich is like German or Austrian or that side of Europe. Freundlich's adsorption isotherm. So this guy, like based on all the experiments of the isotherm, he worked out or derived this particular equation. So x by m is equal to k into p raised to the power 1 by n. So in this, x is the mass of the adsorbate or mass of the gas adsorbed. M is the mass of the adsorbent. P stands for the pressure. And K and N are basically constants that depend on the nature of the gas and nature of the adsorbent. Like they're just inherent properties of these things. So depending on what gas you're diffusing there and what surface you're using, that will decide, okay, what is the value of K and what is the value of N. So another important thing is, because we have 1 by N, N is always greater than 1, and it always takes integral values. N is never negative. It's always greater than 1, always takes integral values. Okay, so X by M, you can see X is mass of the gas that is absorbed, mass of the adsorbent. So basically, how much gas can accumulate over like 1 kg of the solid or 1 gram of the solid. You know, like if I take charcoal versus water and charcoal versus like water vapor versus charcoal versus oxygen, then say 1 gram of charcoal, it may absorb 3 grams of oxygen or 30 milligrams of oxygen, but it may absorb only like 5 milligrams of water vapor, like that sort of a thing. So X by M is literally the fraction of the gas that is absorbed per unit mass of the adsorbent that you're using. Mass of the gas absorbed upon this thing. So based on this, you can see, you can like measure adsorption, like kitna adsorb hua. So that fraction of the gas that is absorbed per unit mass of adsorbent is equal to K into pressure raised to the power 1 by M. Basically, it's directly proportional to a root of pressure. It is so so once you guys have finished writing this down, we'll go on to the graph and I'll discuss like what is the physical significance of it. Like what does it mean when you're actually doing the adsorption? Okay, so Dhriti I think is done. Mitali, you also done?
Done.
Okay. Ansh and Shantanu, let me know when you guys are done. And we'll do it. We'll just do adsorption today. I'll go a little slow only today. Yeah, Shantanu.
Miss Mitali has left the meeting. I think some network issue.
Yeah, she was stuck like a minute ago. Was not moving. Shantanu, what's up?
Writing done.
Oh, okay. All right. So based on this, okay, first think of a situation like adsorption matlab you took a solid piece and you're diffusing like a bunch of gases and you want these gas molecules to be adsorbed on the surface of it. When I increase the pressure on the gas, like wherever this whole experiment is taking, if I increase the pressure, will it be like, what do you think will happen to the adsorption? Will the quantity of gas that is absorbed be more or less? Will it increase or decrease? What do you think? So as pressure increases, how much?
I didn't catch that. Could you try again?
Sorry about that. Yeah. So as pressure increases, if I increase the pressure, will more of the gas be adsorbed or less of it be adsorbed? What will happen to the quantity that is adsorbed? And Shantanu, what do you guys think?
Could you repeat the question?
So, like I'm absorbing a gas over solid. So if I increase the pressure here, will more of the gas be absorbed or less of the gas be absorbed?
More, I think.
Okay, Dhriti is saying more.
I don't know.
Imagine it, no? Think of it. So there is gas.
Does adsorption have any categories or like some specific situations or something?
No, adsorption happens, it's happening on the surface. Matlab, these molecules are being accumulated. One thing, the cause of adsorption is like there is van der Waals forces of attraction between the surface molecule and the gas molecule. Yeah, so force, attractive force hai, so pulls the molecules towards the surface. So now when I increase the pressure, what do you think will happen to the gas molecules? Like, will they come closer together or will it not?
Come closer.
Right. So when it comes closer together, do you think that will make it easier for more of these particles to fall on the surface, or will it not affect it?
I think more particles will come.
There you go. That is correct. So that means more particles are falling here. You're literally like, think of it as when I'm increasing the pressure, I'm pushing the gas molecules to go get adsorbed on the solid. So as pressure increases, adsorption also increases. Like how much of the gas is being adsorbed increases. That is X by M. So X is literally the mass of gas that is adsorbed. So that mass of gas also increases. So Freundlich's equation gives you exactly how it is, what is the relation. Is it directly proportional, exponentially, logarithmic? Kya hai ye? So that is what this equation explains. So as you keep increasing the pressure, this is what happens. So if how Freundlich came at this equation is, he practically measured the values, like he kept the temperature constant, and then he took, like he made a gas be adsorbed on a solid, and then he took the measurements at different pressure values. Like, okay, 1 atmosphere mein kitna gas is being adsorbed, 2 atmospheres mein how much is being adsorbed. That way he took different values, plotted it, and this is the kind of graph that he got. Initially it's straight, and then slowly kind of it's like a curve. Okay, so this is what the thing looks like. So isotherms, na, so all of this is at a particular temperature T. If I increase the temperature, you get a similar shape, but slightly higher. So on increasing the temperature, more of the adsorption is taking place. Sorry, like physisorption decreases as you increase the temperature. It's inversely proportional. So this would be at a lower temperature. So as you keep lowering the temperature, like the shape remains the same, but the extent of adsorption increases this way. So these are all the adsorption isotherms. So on the x-axis you have pressure, y-axis you have X by M. So these are adsorption isotherms. Okay. So the equation associated with this is this particular equation. What each of the variables stands for, put it here. This is the isotherm, the graph related to this. Okay, so it tells you how is the rate of adsorption at a specific temperature, how is it varying with the pressure. And even if you keep the pressure constant, let me just draw a line at a specific pressure, you can see the variation with temperature also. So at a higher temperature, if I call this T1, this is T2, this is T3. T1 is the greatest, followed by T2, followed by T3. So as temperature increases, the rate of adsorption is decreasing. You can see that it's lower on this particular axis. Just this is what Freundlich found out, and this is how you read and interpret the graph. That's it. Okay. Go through it, draw it. Let me know when you're done, then we'll go to the next part. Any part that you're not able to understand, any part that's not making sense, let me know. We'll repeat that. Otherwise, we'll go on to the move forward. Dhriti, are you noting down or?
Ma'am, sorry, can you give me like a minute to note it down? Could you just go back for a second?
So have you noted down the equation? Freundlich.
Yes, ma'am, that I have.
Uske baad this. So this is like when you draw the graph, compare the values, this is how the shape is. So according to the equation, as pressure increases, the amount of adsorbate, the gas that is adsorbed, that also increases. So that's what X by M is. But it's not like a linear increase. This is what the graph looks like. And each graph is at a constant temperature. So that's why it's an isotherm. And the relation with temperature, like at a specific pressure, if you keep increasing the temperatures, the amount that is adsorbed keeps decreasing. So T1 is the highest temperature, followed by T2, followed by T3. You can see the amount of substance is decreasing with each graph. So that's like the interpretation of the graph. Okay.
Ma'am, could you repeat the interpretation of the graph?
See, as pressure increases, the amount of substance also increases. It's not a linear increase. Like initially, it's at lower pressures, it's pretty steep, and at extremely high pressures, it kind of runs into a constant. So we learn what it means in a bit. And each of these graphs are at constant temperature, which is why isotherms. Now, if I change the temperature and keep plotting this graph, so as the temperature increases, the graph goes lower and lower. So at lower temperatures, the adsorption is the highest, which is what the T3 curve shows. Then if I increase the temperature slightly, I get this one. If I increase it by much more, I get this one. So like that also you can get the temperature relation also by keeping the pressure constant. That is what the pink line is. At a specific pressure, if I compare the quantity that is adsorbed at different points, So at T1 temperature, it was this much. At a lower temperature, T2, it actually increased. It became this much. And if I decrease the temperature further, I get this sort of value, like curve yahan pe aa jayega. So as temperature increases, the quantity adsorbed decreases.
Shouldn't the quantity increase as we go up the graph? Oh wait, it's x by m. That's why it's decreasing, right?
No, nothing to do with x by m. X by m just tells you, like, for in say if you're comparing 1 kg of the like charcoal or nickel, how much gas has been adsorbed on it? That is x.
But
then
then why is it decreasing as we go up the graph?
what sort of a process is adsorption? Exothermic, endothermic?
Endothermic?
No, we discussed
It
this.
releases energy.
Yeah.
Delta H is positive, correct. Sorry.
Negative. So basically that's exothermic. So Le Chatelier's principle. Exothermic matlab lower temperatures are favorable.
Yeah. Okay. Okay, ma'am, got it.
All right. Ansh, Shanti, you guys done noting this down?
Yes, ma'am.
Okay. All right. Now let's get the equation back. What was Freundlich's equation? Adsorption isotherm ke liye?
Ma'am, what is what?
What is Freundlich's equation? Like abhi graph draw kiya na, uska equation kya tha? Like you just
X by m is equal to k dot k into p raised to 1 by n.
अभी exponents है, तो apply logarithm on both sides. What will you get? Logarithm of x by m is equal to RHS में, can you simplify it and tell me what is the final thing you get?
Ma'am, the constants k and n, are they like specific to specific
Yeah.
reactions? Like,
Yeah.
okay.
Depending on what gas, what solid you take, that's what they depend on. It's like nature of the substances involved in the process.
Okay, ma'am.
And Shantanu, can you guys like switch on your video?
Ma'am, I got logged out, so that's why I've kept my video off.
I figured kuch network issues hai. Yeah. Dhriti, you also, I mean, yeah. But Ansh and Shantanu, where are you guys?
Miss, in the middle, your voice started lagging. That is why I shut my camera.
Okay. Shantanu is here. Okay. Solve करके बताओ क्या आया? Or do you need help? Like tell me, at least tell me what is the next line. Logarithm of, okay, I'm just applying k into
X.
p power 1 by n. Abhi x by m, let's leave it like this. Let's do this only. How can I expand this?
So it'll be k you remove outside because k is the constant. So it'll be k log p raised to 1 by n.
No, this is k multiplied by p, no? What is?
Right. So you do log k plus log p1 by n.
Yes, log k plus log p raised to the power 1 by n. Now, can I do anything with the 1 by n here? So log k is like a single constant that remains as log k. Then can I simplify this in any other way? Exponent hai, so then Dhiti, what you said will happen. Exponent will get multiplied. This will be 1 by n into log p. Okay. Okay. Some more analysis on this equation. Remember I mentioned n only takes integers and n is like greater than 1. So if n is greater than 1, what will be the range of 1 by n? What all values can 1 by n take? Minimum value, maximum value?
Ma'am, I didn't note down the point where n is greater than 1. Like, could you like explain that?
N is like a constant, right? Like k and n are constant. It's just a property that n can only take integer values greater than 1. So n can be like 2, 3, 4, 5, 70,
Okay.
49.
So minimum value will be like 2 and maximum value will be,
Yeah.
not really sure.
Maximum value will be like, what is the highest value possible? Like math students should be able to say this.
Infinity.
There you go. Now you have minimum and maximum for n. Uska reciprocal leke, what will be the minimum and maximum for 1 by n?
1 by 2.
1 by 2 is
Minimum.
0.5.
0.5. So that's minimum or maximum?
Minimum.
Yes, 1 by n. Okay, 1 by 2.
No, one. Yeah. So a 1 by 2 is the maximum, and 1 by infinity.
So 1 by infinity is?
Minimum.
What is 1 by infinity? Value kitna hai? 0. So 1 by n will range from 0 to like value less than 1. Okay, 0.5. Okay, integral values. So if you apply that to this equation, when 1 by n equal to 0, what will log x by m be equal to? Ansh, what do you say? What will this be equal to? It is a simple mathematical calculation, guys. Something you can easily do. 1 by n value, put 0 and tell me what you get.
Miss 1. If we put 1 by n as 0, then log p also becomes 0. So that remains 0. And k is the constant. So log x. No, it should be x. I mean, log 1.
Ma'am, shouldn't you just get like log k?
Log k is x.
So this is 0 into log p. तो ये पूरा 0 बन जाएगा. Log x by m equal to log k. ठीक है. So if k is a constant, what can you say about the logarithm of k?
It'll be log 1 dx. So 1 becomes x.
Dx, you're not differentiating it. I just substituted 1 by
Sorry, log. Oh, yeah, sorry.
this will
So it'll be log k only then.
log k, yeah, which is basically some constant.
Yeah.
ठीक है. So if log x by m,
Sorry, miss, I was mixing integration
ah,
and everything.
right. If log x by m is a constant, taking anti-log of it, then x by m also will be constant. Which means that when, like, at extremely high values of n, like when 1 by n is almost 0, basically the quantity that is adsorbed will not depend on the pressure. It's going to be a constant value. And other cases, when this value, like either 1 by n can be 0, or when log p is tending towards 0, x by m is a constant. Okay. Which means basically at extremely high pressures, the quantity that is absorbed will remain constant. Basically, the whole surface gets saturated with the gas that is there. So whatever pressure you apply, it's not going to affect, like more and more is not going to be applied there. Okay. And on the flip side, when 1 by n is equal to 1, like, or the higher the other side of values, when 1 by n is like on the higher side of values, then log x by m will be equal to some constant plus log p. Like यहाँ पे ये factor चला गया, which means that x by m is basically directly proportional to the pressure. So it becomes almost linear, which is what this graph shows. So at extremely low pressures, this is almost like a straight line. And at extremely high pressures, this becomes a parallel straight line where the quantity of x by m becomes a constant. Okay, so at low pressure, it is almost a linear relationship. And at high pressures, like basically the adsorbent becomes saturated. So the quantity that is adsorbed will remain constant. It won't change with pressure. It will become independent of pressure. So that's like a physical significance of it. So I'll just write it down here. Or basically that is it. Like at low pressure, this becomes linear, which means that Freundlich's isotherm, that particular formula will kind of fail, because during extreme cases, this is what will happen. Okay. Cool. So this is Freundlich's isotherm.
Can you go to the next slide? I just need to copy that.
Yeah.
What's N and M?
Done, ma'am.
Shantanu, what is, so M is mass of the adsorbent, the same thing what I had put down here. So M is the mass of the adsorbent. मतलब adsorb करने के लिए the substance that you took, the solid substance, कितना mass लिया? 1 kg, 2 kg, whatever. N is a random constant. So, okay, not completely random, but it's like a constant that is related to what gas you took and what adsorbent you took. That's a constant. So K, N are constants. M is mass, X is a mass. P is pressure. ठीक है? Okay, I think I'll end it here. We just have one more, like, so this we talked about pressure, matlab it's adsorption of a gas on solid. After this, we just have adsorption in a solution. So pressure turns into concentration in that case. And after that, catalysis and colloids, let's do it tomorrow. फिर applications है, again that's all theory only. कहाँ पे देखते हो adsorption, where is it applied, that you can study just so many different points. So tomorrow I'll directly start catalysis.
Miss, why don't we have physics classes?
So chemist, I'll just